Okay. So, we're going to take a look at the list abstract data type. And again, our intention is to sort of generalize things so that you can piece together, kind of these pieces so that when and if you're required to make an abstract data type of your own, then that's possible. But I will say that, it's not going to, like she said, it'd be linear, right? So it's not going to be some like completely new weird alien looking thing. It's going to be a linear thing, but it's just going to have different requirements probably.
Yeah.
So, so if you guys aren't familiar, usually when you open up Eclipse from scratch, you take your source folder, and in your source folder, you have your package, and then in your package, you have your class. So that's sort of the hierarchy there. So the class that I'm going to create is an interface. But also another thing is, I don't know if you guys know this, but you can create an untitled text file. So what I'll say here is, and this is going back to that point of generalization, is usually we have like, the interface, right? And we know that the interface is sort of the contract, right? The contract between the class, between the class and the interface itself, right? So in here, we're only expecting what? What do we have in the interface?
Just the headers.
Just the headers, right? So method headers, right? And can anyone tell me what how do we actually establish this contract? Sure, we create the interface, but what is the keyword we use in the class to link that interface with the class? Implements, right? So it's implements. Keyword is implements, right? Extends is for inheritance, okay? And so you usually start with the interface, right? And so the interface just sets all the requirements down. It has all the method headers. It's like a laundry list or a shopping list. Like, okay, I want beans, eggs, and cheese. So this is kind of like, okay, I want an add function. I want a delete function. I want to remove, so on and so forth. And then since we're focusing more on node-based implementations, you're going to have a node class, right? A node class. Now, we called this tree node for one of them, right? And then we also called this, I think, maybe binary node, and then there was another one. I think it was maybe it was just node itself. But the point being is you can call this whatever you want. But the implementation is more or less the same. However, I will say that with a binary node, these nodes, they're different in that they have two links to them, right? Because they have to have two children. So each node has to have, two links instead of one link. But we're kind of focused on the easier one. So the interface, the node, and then the class itself, right? The class itself. And so this is the implementation of the ADT.
So the data structure, is that?
Yeah, exactly. Like the actual implementation of it, right? So like, like when we create the list, we'll have the list interface, we'll have the node class, right? And then we come to the class itself, where we actually take those nodes individually and we build the thing out, right? So we're going to start with the interface, and you actually have to come down to the I here for interface. And what we're going to do is we're going to say, okay, well, this is going to be our list interface. Okay, so whatever it is, right? It could be some other X interface. You just say list interface or some other interface, and usually they're generic, and you can actually make them generic here by typing, two angle brackets with a T inside. And really what I mean by generic is that they can work with any data type, right? If I put string here, then these method headers could only have a data type of type string. So I'm putting T just for, in a general sense, you can have any kind of data type you want. And that makes it, more general. And in some sense, you could say it makes it generic, right? And general, generic, those are, kind of the same thing. But so in this list interface, we're going to have an add method, right? So public and then void and then add. Now, the thing is, you could say, well, whenever you're adding something, it just makes sense that you must have something to add, right? So you could say string item, right? You could do that. But the thing is, whenever you're working with generics, you want to say, okay, well, it's up to them as to what type they want. So I'm going to put T instead of string, right? And so that's sort of the add method. And then, let's say we had a remove method, right? So, and it will return true or false whether or not the removing is successful. So do you think I should just leave this empty, or what should I put inside the parameter, if I should put anything at all?
T item.
T item, right? Because you have to specify an item to remove. And then this one's also an important one. This one's called find. So this is going to return true or false on the basis of whether or not you find an item that's in the list. What about this one? Do you think this should have parameters?
I would say yes.
Yes, right? Because it makes sense to say, okay, well, if you want to find something, if you go up to someone, you tell them, I want to find something, what's the first thing they're going to ask you? Find what? And so that's kind of what you want to do. So like if you're coding an add method, hypothetically put yourself in a situation where you're in front of someone and you're saying, I want to add something. They're going to tell you add what. So this is something you have to specify, remove what, find what. And so this is kind of, that's kind of the basic one. So remember, list, or an interface in general, contract with the class. You have a generic type, and then you can add any kind of requirement, just method headers, no implementations. And then that's that. So
What's the difference between find and locate?
Find and locate. So find is gonna, well, I mean, I think locate would maybe return the indices of where it is. I mean, it depends on what, like, there's no strict definition. I mean, it is how you code it. So if you want locate to do what find does, well, you just call it locate. Or you kind of see what I'm saying?
Yeah.
Or maybe find just returns the value of what locate does, right? Someone else was saying something.
Yeah, I was going to say, so if I understand this correct, she will tell us, the 3 words, add, remove, find, and tell us what she wants them to do.
Yeah.
Right?
Yeah.
So
Definitely.
on the interface, she'll tell us these are the 3 headings that you need to have.
Yeah, I believe she does do that. She's very specific. I think she says, oh, well, it should be public, it should return a Boolean, it should be called this, it should take this as a parameter. So a lot of this is not that, this isn't the problem, right? Right. So yeah, for sure. Yeah, this stuff is told. Yeah, I mean, in my experience, at least with her, I mean, when we're given it and stuff. And so, yeah, so I mean, there's that. So the node based, right? Or not the node based, but the node itself. So this is kind of, the thing that everything kind of revolves around in some sense. And it really doesn't change. So we can call it node, or you could call it list node. And I will say it would be of type T. And the idea here would be, well, okay, we'll have, these would be private. Let's see here. I think someone's trying to get in. 1 second. Let's see. Let's see here. No, okay. So where were we? Yeah, so we're gonna have a private variable, and it's gonna be you could go with the data first. You can say, well, this is gonna be my my piece of data, and then in addition to that, you're gonna have your a node itself, which is gonna be the link, right? So each node, you can imagine it as this little field which has data associated with it, but then in addition to that, it has a link, right? And so this piece of data, so the whole thing is a node itself. And within the node, you have the data, and then you have a reference, which is of type node, and it links to the next node in line, right? So it's gonna, I think there's a picture of this as well. But you kind of have this chain of nodes, each of which contain these two fundamental things. Does anyone kind of know the hierarchy between, like, for a class? Like, I have my instance variables here. What are two other things that usually come with a class?
Get and set.
Get and setters. Okay, sure. Yeah, that makes sense. Anything else?
Constructors.
Yeah, constructors, right? So you have your constructors. So the constructor must be the same as the name of the class, right? So we'll have node here. And whenever you're creating a node, it could be convenient to add the data to it, right? So you can say, well, go ahead and add the data, and then you're going to have to tie this data that they provided, and you have to make sure that it's referencing the data that you had up here, right? So because there's a difference coming into it, coming into the constructor, they just throw some data in here. And I mean, you have to be able to say, okay, well, this data that they've thrown, it has to correlate to what I treat this data to be on the class level. So you have to say, okay, well, this dot data, the data that I have, that I've passed in is equal to, these two are equal, this data up here and this data. Of course, you could make this, you could say, okay, well, this is new data, right? The data that's just coming in, and you could say data equals new data. This is just the same thing. You use this keyword if they're both named the same thing, right? If you want to name them the same thing, you say, okay, well, this dot data equals data. There has to be a way to differentiate. What about the link?
One that was on the last programming is she made it the same, so you had to do this.
Yeah, exactly. You had to do, because how would you tell, right? I mean, what's going on here, right? We don't really know what the, what the idea is here. So you say this, right, instead. And it says, like, it, the yellow line means, like, it'll work without it. Like, I mean, it's fine, it'll work. The program will infer what's happening, but it isn't generally good practice. So the data that I have as a variable will be tied down to the data that they've passed into me. And then in addition to that, when you're creating a node, it's just floating in memory. It's not tied to anything. The tying down process is what we do, right? Our program will eventually take care of tying these nodes together. But we say, okay, well, this dot link in the, that we have up here is essentially going to be null. It's not going to point to anything in the beginning. So you every time you create a node, it's not linked to anything off the bat. It's just something this is floating, and it has data in it, and its reference isn't pointing to anything, so it doesn't have, it's not in the line yet. And so these are two fundamental parts of creating a node. And then, of course, like Carol said, I mean, you'll have your something to get the data. I'm adding a return type here because the get data method, it returns this dot data, right? The data on the class level. But it doesn't make sense to get something that you can't set, right? So we're going to set something. These setters, they're always void. That's specifically because you're not expecting a result when you set something, right? You just change it. And so nor do you and then you have to pass something in, right? You have to say, okay, well, I'm going to set this data, and then whatever data I've passed in should now be equal to the data I have on the on the field level, right? So you have set data, you have get data, and then so this deals with sort of this first instance variable data, right? We had the setter, we had the getter, but in addition to that, it makes sense to have a getter and setter for the link, right? And so for the link we have, so we just say, okay, well, there's going to be a set link, right? And for setting the link, again, those are void. All the setters are void. And we have a generic type for the node that we're passing in. So because you have to, like, when you're taking one node and you're setting it to the other, don't you need that other node to establish that connection? I mean, can you connect two things without one of them not being present? So the idea is you pass in the other node. You pass in the other node to the set link. And then you say, okay, well, this node's link is now going to refer to that other node, right? Okay. So if I had node 1 and node 2, I have node 1 here and I have node 2 here. they both contain data and a link, right? They both contain, this piece of, but their links aren't pointing to each other. But when you say, okay, I want to take node 1 and I want to set its link to the other node, you have to pass in this other node 2. You have to pass it in and say, okay, well, this link, node 1's link, will now link to that other node. Does that make sense?
Mhm.
Yeah. So it can't do it without having 2 parties, right? And then the get link is like, well, I'm just going to say get link here, and then I'm just going to return the link, right? The reference. So what should my return type be?
Node T.
Node T. So why is it node T? Why not just T or?
Because you want the actual like
Well,
thing it's pointing at.
You want the data and the link?
So we don't, if we wanted the data in the link, right? So the node itself is the container for the data and the link,
Uh-huh.
right? So we don't necessarily want the data in the link. That's what get data is for, right?
Yeah.
We want the whole node. We want the entire thing, right? You see what I'm saying, Carol? We want the entire node. That's why we're saying node T. So we want the entire thing. We want whatever's in it, right? We want the whole package. We want the data and we want the link. So we want the entire thing. So when we say return link, it's assuming that the node has a link to it, right? Like, you have N1 is pointing to, N2, and then it's pointing to N3. So let's say I'm on N2 here. I'm like, okay, get link. So it's going to say, okay, well, it's going to use its link and it's going to get what the link is connected to, which is a node, right? Does that make sense? So it wants the whole thing. Okay. Does that kind of help?
It does.
Okay. Yeah, because if it doesn't, let me know and I'll flesh that thing out. But so yeah, this is kind of the basic structure here. Again, if this was a binary tree, you'd have a left link and a right link. And then more getters and setters.
Can I ask you an ignorant question.
Uh-huh.
Not every time that we did, all right, so we did array-based and node-based data structures for every one of the ADTs.
Yeah.
But sometimes we had a node class and sometimes we didn't.
Mm-hmm.
So when do we have to have a node class and when don't we?
Well, so the real answer there is that, it's entirely up to you. But the thing is, it depends on whether or not you want it to have a limit. So like if right now we're working with lists here.
Uh-huh.
I could easily just create, I could take all this node garbage and toss it aside and easily just create a list, an array, right?
Uh-huh.
But the thing with an array is that you have to declare the size first. You actually have to say int my list equals new int, and then in this next bracket here, you actually have to specify the size, and it's not going to let you move on until you specify the size. So you have to say like 100 or something, right? Now the problem is, what if you don't know the size in advance? Like, what if you want the user just to be able to keep on attaching new pieces of data?
That's
Well,
when a node would be better than an array.
Exactly. And this comes back to static versus dynamic allocation of memory, right? So to allocate just means to, set aside. So when you statically set aside 100 slots, it's not going to change. It's static, right? But dynamic means, well, it will change based on how you want the user to interact with it. So with nodes, I can just keep on I'll take the last, like if I have a new node, well, I'll just take the last one in line and I'll connect a new piece of data or new node. And then I can just keep doing that. And, it's like I can just keep building this chain forever, essentially. But with the array, I can't, because I have limited them. I've constrained them to 100. And that's not always.
Well, I guess this is the question that I'm asking, and I still don't really have a good understanding of it, but for example, in our list project in class, when we did the node, she had 3 files, the interface, which we just did, and she did the demo, and then she did the node-based list. We're gonna also have to have a node-based list, right?
Yeah,
In what
exactly.
you're doing. But
Oh,
in
yeah.
her example, we didn't have this node class. Why do we have to have this node class?
Are you sure you didn't have this node class?
I don't,
She uses it definitely.
she,
Let's take a look. We'll hash this
okay,
out.
well then, no, that's okay. Then if you guys are saying it, I show I only have 3 files in it, so I'm probably not doing something right. But go
It's-
ahead. So you keep
yeah.
going.
Yeah, it's probably the case, Carol, that like so when she was looking at the queue and stuff, and when she used the node class for the queue, but then also she used it for the list. And because the implementation won't change whether you're using them for the queue or whether you're using it for the list. So it's probably that she just added the new files
Oh,
that will change.
okay.
The node won't change unless it's a binary tree, guys. This is not going to change. I don't see it changing.
Okay.
This implementation is what they would call, standard.
Okay. So you're saying every time I have a node-based list, I should have a node class.
Oh, absolutely. I mean, yeah, exactly.
Okay.
For sure. Yeah, absolutely. So, and this is sort of, yeah, you have the interface and then you have the node class. And then this is essentially how it will look each and every time, more or less. It looked the same for the queue. It looked for the same for the list. And it'll probably look the same for whichever other thing. I mean, regardless of what it's called, we called it tree node or called it binary node, really whatever you want to call it, but
Okay.
it'd be easier.
I
Mhm.
just had a question. For the interfaces, are there any exceptions for lists, or they're just like
Well, so think about it, right? There isn't any, so yes and no, right? You'll never have a full exception.
yeah.
Ever, right? Why, so, and this goes back to what someone else was asking, Carol, why won't we ever have a full exception?
Because you can just keep adding nodes, but if you remove all of them, then you'll have an exception that you're trying to remove from an empty list.
Exactly. So, exactly, that's the idea. So it's a problem when we remove. It's not a problem when we add, because the adding doesn't have a cap, right? But
Yeah.
if we call remove, so okay, so this is a good segue. So let's suppose you found out that, damn, your program wants you to do this thing, which is to create exceptions for stuff like this. So then what you do is you go to your programs or your package and you add a new class. Okay, you're going to create an exception class here. Okay, so the exception class, you can call it what you want. You could say this is a list empty exception. Okay, this is a list empty exception. Now so any exception, and this is the format always. I'm writing down the format so that regardless of how it looks like, wherever it appears, it will always be the same. Public class exception name extends exception. Okay, always. And then you're going to have a public, a public exception name. This is the constructor. It will be default. It won't take anything. It will make a call to the superclass of the exception class. Then you're going to have another constructor, which it will be overloaded. It will take in a message, string message, and then it will have you will pass in this message to this super thing. Okay, and this is how all the exception classes will look. It's how they have looked, and there hasn't been any variety in terms of that. So I can literally just take this template and say, okay, well, the first I extends exception. Okay, so I extend exception. And then now that I extend exception, now I have my first constructor default the exception name, because remember it says exception name. What's the exception name? It's the list empty exception. So I have that here. It's a standard constructor. It just makes a call to super. Then I have a duplicate, but the duplicate changes in the sense that I now take a string, it's called message, and then I pass in message as a parameter to super, right? And if you go back and you take a look at your stack empty exception, stack overflow exception, queue is full exception, queue is empty exception, they've always looked like this, except the name here. The only thing that changes are 3 things: this thing right here, this thing right here, and this thing right here. Everything else is exactly the same. Okay, where would I put this? Well, I would definitely not want to put it on add, because it's never going to be a problem on add, nor will it be a problem on find. It will only be a problem on remove. So I say remove. Okay, just so again, the purpose is not to show you how to create a list. The purpose is to show you how to create anything. So the idea here is that whenever you have, so you say public return type, name of method, and then you say throws. So the thing throws exception name. Okay, the thing throws exception name. And then in your actual body, if the exception happens, you say throw new. So it's kind of like you're describing something at first. You're saying, okay, well, this thing that I created, the name of the method, whatever that might be, it tends to throw this exception, whatever that exception name is. And then if that exception happens, which is why I say if that exception happens, then I'm going to throw it. Throw new exception name. That's option one, right? That's option one, is just to say throw new exception. Option two is to say, well, if the exception happens, throw a new exception, but now I can pass the message. So this is insert message here, right? Okay. So this is kind of how to use these exceptions in your methods. Over here, I actually don't need to add an implementation. I can just say, in the remove, I just throw a new exception, right? So throw new exception, throw new what? Throw new list empty exception, right? Okay. Throws. Oh, it says throws, yeah, throws exception name, remember, right? So it tends to throw a list empty exception. If that exception happens in the method itself, then I'll throw it, and I'll actually throw it. So it's kind of this action diction here, adjective and diction. So or well, you get what I'm saying. And so that's the idea. Does that make sense to whoever asked?
Yes.
Mhm.
Okay. And so into the into the actual thing. So so we're gonna have on the basis of context, what would someone choose to call this? A list? Sorry, go on. Someone said something.
Oh, I said demo, but I'm not sure that's where you were.
Oh no, so the demo would actually come in. It would come in after you create the class, right?
Okay.
So if you have a node and you have the name of the abstract data type that you intend to create, you could just call it node-based list. Okay, so node-based list, and then this would be generic. Okay, so is everyone with me so far?
Yep.
Okay, excellent. So again, this goes back to sort of that template that we had earlier, which was instance variables, constructors, and then methods. And so they all follow. All classes will follow that pattern more or less. And so initially, we would have our constructor node-based list. So and then what instance variables do you think it would make sense to have? Anyone?
Data and link.
So the data and link are actually part of the node itself. Like, remember, so these are different entities, right?
Mhm.
Data and link, these are part of the nodes, right?
Head and tail.
Head and tail. Okay, yeah, it could make sense to have a head and tail. How about just so with the queue, we could have had a tail. We could have had a tail. With the list, even the way that it was taught, we could have also had a, well, we actually know we can't. So this is why we can't have a tail. It's because that lists are unordered. In other words, with a stack, do you guys remember what a stack ordering was? It was the last in is the first out, right?
Mhm.
What about with a queue? The first in was the first out. So this is like a line,
Mhm.
right? And the other one was like a stack of plates.
Mhm.
right? Over here with lists, and this is also something you'll have to figure out, whether or not the data structure you're creating, whether or not it's unordered or whether it's ordered. Okay, because if it's unordered, then there is no, like, there's no ordering. It's not LIFO, it's not FIFO. It's just random placement.
And if it's unordered random placement, it always makes sense just to put it at the end.
No, it doesn't make sense to put it at the end.
Put it
You
at the
wanna-
beginning.
Yeah, it makes sense to put it at the beginning.
Okay,
Do
so
you want to know
unordered-
why?
Probably because, no, yeah, I want to know why.
Okay, so this is why. So I have a lot of elements here. Now I have X's, right? So if I want to add a new X and I have to add that at the end, I'm going to have to go through this. I'm going to have to go through this, go through this, go through this, go through this, and I have to go all the way to the end. And then finally at the end, I'll say, this is my new X.
Mhm.
But it makes sense to just say, well, let me just add it at the beginning and I'll be done with it, right? So I don't know if you guys went over this, but going through the entire set of X's or elements, this is something called an order of n time complexity. Did you guys go over this?
Uh-huh.
Yeah, it's an order of n time complexity. Just adding it to the beginning is an O of 1 time complexity. In other words, it's constant time. It will always take you the same amount of time, regardless of how big your elements or number of elements are. It will always just take you the same amount of time to add it to the beginning. But adding it to the end, it depends on how many elements you have.
Right.
If you have 20, then it'll take you 20, you have to make 20 movements through your collection. And you know, we talk about this in a smaller sense, but imagine if we were talking about 1,000 or 2,000 elements. That's an
Mhm.
expensive operation. By expensive, I don't mean monetary. By expensive, I mean in terms of utilizing resources, in terms of hardware. And so that's kind of what the idea is. So you have to determine whether it's unordered or ordered. If it's unordered, just add it to the beginning. They call this a prepend operation. If it's ordered and it makes sense to add it at the end, then this is called an append operation. When you append something, you add it to the end of a collection. When you prepend, you actually add it to the beginning. Okay. So our list, any list by definition is unordered. Okay. Not any list, like a linked list is actually ordered, but a list itself, like if you have an array list in Java, which is actually underpinned by nodes, I think, this would be unordered. So we're gonna have a private field called node. It's gonna be called list. Okay, you could call it something else. I'm not sure why this is getting an error here. Remove invalid. Oh, no.
Is it because you're inside the constructor? Or-
Yeah, exactly. Yeah. All right. Yeah. So we're gonna have a private field called list. You could call it list, or you could call it whatever you want. I could even call this the head of the list, or it's really just a reference to the beginning. So like if I had this long list, then this guy in the beginning would be called the list, and then this is my entry point to the entire thing. Does that make sense? So the list is actually like, when you say list, it's not the entire list itself. It's kind of like the first node in the list. And when you have access to the first node, you can move through it one by one. So it's kind of giving you access to the list itself. So we're calling it list here, just staying true to what we've been told. And then
That line, I know the constructor is node-based list, the bottom line. Is that an instance variable?
oh, this one up here.
Yeah,
Yeah, exactly. So instance variables first, right? And then constructors. So this is kind of the hierarchy, the constructors, and then the methods. Okay. Constructors, instance variables, constructors, methods. So this is the instance variable, right?
okay.
Okay, and it's kind of the entry point. So the list is the entry point to the entire thing. Then you have your constructor. Initially, the list will be null, right? This dot list is null.
Mhm.
Because you haven't done anything. The list is null in the beginning. And again, we all know that all these classes, they extend object, right? They extend object. This is sort of a preferential point, and then you could say super here, or you could choose not to. I've never seen it required in any of our coursework. to do that, but it's just something that's there. Now, what you'll notice is I'll get an error. What am I missing? I mean, I had an interface here. Is it tied to the class? To this node-based list? Is it tied to this node-based list?
Not yet.
Not yet. So how do I get that to happen?
Implements.
Right.
Implements.
Oh, right.
Oh, were you going to say extends, Carol?
No. I thought you were saying, what do you need to do? You need to have the methods that match
Oh
every
yeah.
header in the interface.
Yeah, I wouldn't even take the time to type that out. I'll show you why. So when you say implements and then implements the list interface, that was generic, right? So why don't I type it out? Because it tells me, it says, well, look, you're trying to implement a list interface, and that list interface has things inside it. It has, you know, a method headers that you don't even have in your class. So this is not going to work. And so it says, well, implement them. It forces you, it kind of twists your hand to do so. And then you say, okay, well, add unimplemented methods so that you actually generate all the methods you need. Do you guys know that?
What would you just do?
Yeah, so like I was saying before, it's not possible for you to have a class that implements an interface and that interface contains things. Remember how I said it was a contract? It's
Yeah.
illegal for you to break the law here and
Yeah.
have an interface, have a class that implements an interface that you don't have the methods of. I don't have any of the methods here. And so before I didn't have this, but now I do. And so it's telling me to, Jesus Christ. It's telling me to, it's telling me to implement those methods. So you hover over the error because the error is going to show up. You hover over the error and then you say add unimplemented methods. Okay.
Okay. Now, so when we created the node-based list before, when you hit class, if we actually added the interface to it, then it would have that little override.
Yeah. Like you're saying, if I hadn't had this, then
Yeah, if you
it wouldn't do
created this node-based list from scratch, you went class, node-based list, and then where it had interfaces and you clicked on list interface, then you'd get those overrides automatically.
if I have implement here, right? Then I
Yes.
get automatically.
Yeah, if you just, yes.
Yeah, if I click that. But the thing is, like, I could implement them myself without like an interface. But I just can't have all this stuff. This wouldn't be tied to the, like, I can create my own, like, okay, I'm gonna say add public, it's gonna be void. This is my own add method. Like this is something I'm doing personally. But when you do that implements like list interface stuff, it's forcing you to have everything that the interface has that it has described for you. So these are requirements. Requirements aren't optional. So you add the unimplemented methods and it generates all the this is what they call boilerplate code. You'll hear this a lot in in actual development. They call this boilerplate. Like all like public static void main string args, that's boilerplate code. It's code you need to write code, right? So it generates all this boilerplate code for you to it's like a template for you to actually populate each of these. Okay. And interestingly enough, it even throws the exception for you. So it's the whole package, right? So there's that. Now it really all starts with the add method. But in terms of what I was saying before, generalizing things, what I was trying to say was, like, whenever you're adding something, always take into an account the first element. Okay. So what do I mean by that? So I would say, okay, well, if this is the first element I'm adding, if it's the first element I'm adding, then, so if this is the first, well, okay, well, let me back up here. You have an item. Okay, they passed in an item. And the item, your list consists of what? Does anyone know? What does your list consist of?
No.
Nodes, right? Does it consist of items?
Yes.
It does, right? It does consist of items, but the items are in something else. They're inside the node. So the list itself on a more specific level actually consists of nodes, and it just so happens to be the case that the items are within the nodes, right? So really, when you know, you can't really work with this because you can't just say, I'm going to create a list of items. You know, you're creating actually a list of nodes. So whenever you're adding an item, you actually have to put that item in the node first. Does that make sense? So I actually have to create the node. I'm going to call this like, you know, this is the new node here, equals new node. And then I pass in the item to it. Okay, so that's what I'm saying. You're building a list of nodes. You're not building a list of items. So when the item comes in, you have to actually put that in the node first, and then you can start building. Does that make sense?
Mhm.
Okay, yeah, because that's the point of confusion oftentimes. They're like, well, why didn't you stop at item? And so the idea now is that, well, hey, if I like to call this head, usually treat it as head, honestly, like this is the head of the list. But if the list is null to begin with, like, you know, that if the list is null, then what should be my logic here? What does anyone know?
List.next is
List.next. Okay, someone said list.next is what?
the new node.
The new node? Okay, but this assumes that the list already exists. The list is null, right? So look, what I'm saying is this: if the list is empty, what do I do here?
Oh, could you just say list equals new node?
Yeah,
Like
exactly. I say, hey, look, the first node is actually the node I just created. So I'm like, well, if the list is empty, there's nothing there. Well, then what's the first guy? It's the new node that I just created. So I say if the list is null, right? Because remember, in the beginning, you actually have a list that's just null. It doesn't have anything in it. So if the list is null, then that new node that you just created, well, guess what? That is your list. The list is actually the new node. Does that make sense?
Mhm.
Okay. Otherwise, well, what am I looking in this else case? What's happening in this else case? That means I have plenty. I have like, you know, I have plenty of nodes, right? This is not the first. There are many that can, you know, there are many that that were added to it, right? So what do I do here? What do I do here?
now is it list.next
Okay, so we say list.next, okay,
equals new node.
equals the new node. Okay. Yeah, I mean, this is or you know, well, next, so we have like what we have in our nodes are, you know, set data, get data, set link. You could set the link, right? So that's kind of how that's kind of how we would do it here is we would say, well, you know, the list dot set link will be the new node. But see, the problem is that's only going to work. So let's say this is what I have, okay, and this is my list. This is, you know, the thing that this pointer is pointing to right now. This is the list, okay. I'm coming into this. This is my list so far. It's not empty. I already took care of the empty case. This is my list so far, and we're pointing at the first thing. And then you said do this list.next equals new node, right? Well, list.next already is pointing to something, isn't it?
Yeah.
Right. So what do we really have to do? We have these 4 or 5 guys already here. So we can't say list.next. Well, if you do list.next and set it to new node, well, I mean, there's already something here. Any other suggestions?
At the front of the list?
You could do it at the front. You could do it at the back, right? So you would have to traverse, and this is actually something that I think was on the previous exam. You had to traverse the entire thing. Then you had to stop right here. And then you had to connect this guy's link to the new node.
Mhm.
Okay. But it's unordered. So why, who cares? It's unordered. So what we're going to do is we're instead going to say that this this list, we're gonna say we're gonna take this new node and we're gonna, I wish I could draw this out. One second. Can everyone, okay, one sec. Okay, does everyone see this here?
Yeah.
Okay. Good thing my history isn't up because that would have been insane. I'm joking. Let's see. Let me just pull something up here. Okay, so look, at this point in the program, we've just created the new node. Okay, this is the new node. We've just created it, and this is the list already clearly exists, right? There are already things inside. You know, there are already elements there, and this thing is our list, right? This is like the first node. This is the first node. So you could traverse each and every one of them, and then stop at this guy right here. You could stop at this guy. And you could tell this guy, hey, look, I'm going to take your reference and I'm going to point it to this new node that was just created, right? And then you could stop there. But a more better approach is just to take this new guy and just point it at the head. Okay. Does that make sense?
And then point the head at the new node after.
Exactly. Now the new node is what? Well, the new node, well, now the head of the list is what? It's this guy.
Yeah.
And so every time I want to do this, this is all I have to do. I don't need to go through going through thousands of elements. I just have to, I just created a new one. I just created a new one. Now I take this new one, I take its next reference, I set its link to this guy, and then, yeah, that's all I got.
Okay. Okay.
You get, and I get to build it on just like that. And then that's how I built these. So, that's the idea. This is a cost-efficient solution, right? Okay. So just like you said, you're just gonna take this. You're gonna take this new node. You're gonna set. You're not gonna set its data. You're gonna set its link to the list, right? Does that make sense?
Mhm.
Kind of what we did here, right? We took the new node and we set its next pointer to the list, right? The current head, right? We did that. And then what did we do?
Have the head point to it.
Yeah, now the list is something else. The list is like the beginning of the list is now the new node that we just created. Okay. So that's really the idea there. That's how the add method works. And that's actually honestly all I know about this topic. I'm joking. But yeah, so did you guys follow that? Is that cool?
Yeah.
Okay. And then the remove method. So the remove method is kind of well, you have to first figure out if there's anything to remove, right? So how do you do that? How do you do that?
If it's not null.
Yeah, exactly. If the list is not null, then it's possible for me to remove something from the list if the list isn't null. And then, so this is kind of where we have to, this returns a Boolean as well. So, and you know, this is going to be a Boolean value. And actually, you know what, before we go through this, let's verify the code we already have. This is a good exercise. How can you verify everything works so far before going on into all this nonsense? Go ahead, create a demo. Okay, we'll call this list demo. And you can actually verify things here. So you could say, so you have this, right? And you're like, okay, well, I just created this node-based list, and I'm going to comment, or I'll just return false for now, just to satisfy it. Okay, so I just created this add thing. I want to verify that this works. So how do I do this? So I go to my list demo. I say, okay, well, I'm going to create the node-based list. I can have anything. I'm going to say type string. I'm going to call this my list equals new, let's see, node-based list. Why is that not really? Yeah, okay. I just created this. So I'm gonna do my list dot add because I have that add method. I can add things. I'm gonna say, my own name, and then I'll say, Carol. Who else do we have here? Someone shout their name out.
Van was there.
Van.
June was there,
June is there. June, are you there? Van?
They were, I don't know.
Okay, all good. So you have both of these, right? Rom, Carol, Van, June. So, I mean, I want to verify that all these elements were added, but how do I do that? So you go back into your node base, you can create a toString, okay? And then that's all, or you could do like a print, right? A print thing. We'll do toString, okay? So public string, toString.
You're in the node class, right?
Oh, Jesus Christ. Yeah, I'm in the node based list.
Node base, that's where you're, so why wouldn't you do the print just out of the demo?
Um,
Can you do,
yeah, well, why can't I do it? So this is why I can't. I can't because the list itself is private.
oh,
Okay. And its nodes are also private. Like if I come back here, its data is private, its link is private. But I can access it. Like if I say my list dot, I have to use this, let's say, like I don't have anything that will give me access to it. So I'm creating a toString inside here that would be public. And then that way I'll be able to access it, if that makes sense. Okay, so in my node base list, I can come down here, I can create a toString, public string, toString. Okay, it returns a string. This is going to be, the string version, right? Okay. And I believe the problem is that I need to return the string. Okay, so what I'll say is, so this is called linear traversal. This is an important topic, linear traversal. So what you do to traverse, does anyone know what to do to traverse the list? Does anyone know how to do that?
You start at the head and then
Yeah,
you just go through.
You just go through. So you have the list here. Okay, you have the list here. What you do initially, and remember the list is actually pointing to this guy here. So what you do initially is you create a new node, right? It's called current node.
Oh, sorry, we can't see
you're
what
not
you're on.
in,
Oh, okay, sure. So you create, do you guys see this?
mhm.
Yeah, so you have your list, and then you actually create you have your list, and this is everything we have right now. And what you do is you create a current node or some reference, and you tack that onto the list itself. Okay, so this is where we are currently, and then we'll work our way up. So we say, okay, well, node T, it's like a dummy node, like current node equals, it's gonna be at the list. Okay, it's going to be at the list. And then what happens is you basically move this along. So you take your current node and now you move this along like this,
Mhm.
like that. But the question is how to do that. Well, on one iteration, well, first of all, when do I stop?
When null, when you get link equals null.
When the current node is null, right? Because eventually the current node is going to be pointing to null, right? So I stop when the current node is null, right?
Mhm.
So basically I'm fine to I'm fine to say, okay, well, while the current node is not null, right? While the current node is not null, keep moving current node along, current node reference along. Does that make sense? So while it's not null, I get to keep moving it along. And how do I move it along? Well, I do current node dot, current node will equal the next node. Current node dot get link. Does that make sense? So do you guys see what I did here? So I just said that, I just said that, you know, on one iteration, what's going to happen, current node will be set to the next guy in line. Then on the second iteration, current node will be set to the next guy in line. Then on the third iteration, current node will be set to the next guy in line. And then this will keep happening until the current node is null. And that's actually how it moves along. Does that make sense?
Mhm.
So that's the idea there. Now, what you want to do with that is you could do anything. I could print the data out. I could I could just call this, you know, I could say this is void, and I could just call it print. And before moving it along, I'll just do system.out.print. Current, whatever current is currently pointing to. And I'm just going to get the data. Okay. And I'm going to toString it. And so this would work. And so if I come back in my list demo, and if I say, you know, my list dot print, please work. This is going to be so embarrassing if it doesn't.
We don't care.
I'm joking. I know it'll work. June, Van, Carol, and Rom, right? So see, that's the idea. So I moved that along. Now, what would happen if? Can anyone tell me what would happen if I didn't do this?
It would just print the first one out.
The first one. Okay. Any other suggestions?
Go back to what you want us to put. You
So I
said-
had this before,
Mhm.
right? But I removed that then.
Yeah, I think it would just
Probably the last one.
It would
So
print the
June.
last one out. Okay.
I don't know. A wild guess.
Yeah, sure. Wild guess. We have the last one in the room. We have the first one in the room. So think about it. We'd come in here. Forget this for now. We'd come in here. We'll tack that current node onto the head of the list, and it'll say while current node is not null. Okay. It'll say while current node is not null, print current node dot get data dot toString. Then it'll come back again. It'll ask, is current node null? Then it'll print current node dot get data dot toString. Then it'll do the same thing again. It'll say, is current node null? Then it'll print current node dot get data dot toString. So it's always going to print the same node an infinite amount of times because current node never moves up, and therefore it never gets a chance to be null. So so when we come back to the list demo, when we say we say my list dot print, it just prints June out like infinitely. Like I actually have to stop this, and once I do stop this, look at how many Junes we printed. Like these are all, you know, June doppelgangers over here. Okay, so you actually have to have it move up, and this is so important, honestly. Like I don't see how you could have a linear data type where you wouldn't have to use this functionality. So current node will equal the next node in line. That's so important. Current node dot get link. Okay, and then it works. So are we all on the same page with that?
Yep.
Okay, for sure. Okay. And then so this is actually, I called this print, but you know, more often than not, you'd probably see toString here. This is going to be a toString method. And instead of printing out the data, I'm going to have a string up here. It's going to be called, you know, what I want to return, right? Or what I want to return. You could call it whatever you want. Okay. And the idea here is that you'll say, okay, well, it still has to move up, not going to change, but the logic will change. The logic will say that what I want to return will equal what I want to return, what it was before, plus current node dot get data. Okay. Does that make sense?
Is it okay to put like a new line at the end?
Yeah, that's
So
what I
we
was
can-
going to get to. I was going to ask if I did that, what would the problem be? And the problem would be that all these would be merged together. So if I do toString, I actually have to print this out, right? So I'll say system.out.println, and I say, you know, my list.toString. And then I actually print this out. Oh shit. Okay. My list.toString semicolon. Like, what would be the problem here if I did this? One sec here. That would be list what I want.
Oh, you haven't
Yeah,
returned
return toString, yeah. Return what I want to return. I really just want to hammer in the point that there's no right way of doing this stuff. And it's up to you to, not in an exam, obviously, but you know how it is. Oh, geez, what happened? Did I save it? Oh, to public string. It's called toString. See how there's no spaces? It just says June, Van, Carol, and Rom, and we're just so close to each other. And so what you want to do is you can add, you can either take the easy way out, just add a space at the end, and that'll take care of it. Or someone was referring to a new line. Actually, they're called something called escape characters. You can escape the new line by doing a /n. And then what that does for you is, well, it'll generate them on a line. It'll, every time it does it, it'll cut to a new line. And so this is testing. This is testing whether or not that one function works, because we've only added one function, right? And so when you go through that add method, just test it real quick and be like, okay, can I actually add them all, and will I get them back? And so that's the idea. Okay, so that's, yeah. And also, what you'll notice is, like, they're not in any order, like Rom, Carol, Van, June. Here I have June, Van, Carol, Rom, right? So they aren't in the order I added them. Okay.
Interesting. Why aren't they in the order that you added them?
Well, remember how I said that, like, if I had done this, okay, I'm going to show you. If I had, remember how you said that, why don't you just add them at the beginning?
Mhm.
So that's kind of why, like, I'm just taking, like, I added Rom, I said Rom, Carol, Van, June, but every time I added, I kind of like,
Oh.
yeah, I messed up that alignment by being like, I don't want to add you after, I'll add you before, just because it's more effective to do it before. Like, I don't have to go through all the elements to just add, but I could, and I'll show you. So what if you wanted to do that though? What if I wanted to do that? Like, what if I didn't add it at the beginning? What do I do? So I have to traverse the entire thing. Okay, I have to traverse the entire thing. I have to create a new node, right? So, or not a new node, but I have the new node. I'm creating a node of type T. It's going to be called current. It's going to point at the list. Now, while that current is not null, okay, while that current is not null, do current equals current dot get link, right? Remember, moving it up, right? One at a time. And then, so this is going to take me through the entire list, right? This is going to take me through the entire list, element by element, right? So current node is eventually going to reach what? It's going to reach the end eventually, right? It's going to reach here. Do you guys see the screen?
Yep.
But do I want that to happen though? Do I want it to reach the end? Because I have this new node, right? I have this new node. I want it to be here. But I don't want current node to reach the end. I actually want current node just to stop right here. Why do I want it to stop right here? Does anyone know?
So null could point to the new node.
Yeah, so this node's reference could point to the new node. Then I'll take this guy, I'll be like, whoop, point to the new node instead. I can't do that if it's over here, right? I can't say, point to this. I can't have null point to nothing, or I can't have null point to something. I want to stop here. So right now, the implementation I have, it moves me through every element. That's a problem. So how do I avoid this? one change to avoid all of this.
You say while current node dot get link is not null.
Yeah, while current node dot get link is not null. So what? Explain to me why that works.
Because it just like it just moves like it basically looks one step ahead and is like, is that null? If not, then like no.
So
Yeah.
every link, every node except the very last one is gonna be not null.
Yeah, exactly. Like it's gonna check one step ahead. So over here, it's not checking whether it's null. It's checking whether its neighbor is null. So over here it asks, is my neighbor null? No. Is my neighbor null? No. Is my neighbor null? No. Is my neighbor null? Yes. Stop right here. And then you have an op. So when it stops, you're on the last node. When it stops, you're on the last node. I'll show you. I'll say system.out.print. System.out.print current dot get data dot toString. Or actually maybe that's not a good idea. Well, yeah, else I'll print the last node. Actually that might be confusing, but after the while loop ends, you're on the last node. So what do? You just take, what do you guys do? What do you think? What do you do when you're on the last node?
I'm sorry, your screen glitched out a little.
Yeah.
That's
So what do
pretty
you do when you're on the last node?
You
Because when the
have
while loop ends,
null point to the most current node.
have the what? Carol, say that again.
Have the null point to it and make the newest node be null.
So yeah, I'm kind of, so we'll go back to what we were drawing. Let's see. So yeah, so we've stopped here, right? So we stopped here. Now what's the next step? Remember, each of these nodes, they have data and they have a next pointer or a link.
You have that null point to
This null.
no, you have that current nodes pointing to that. I'm circling it.
Node.
Yeah, that node.
Okay.
And you're gonna have that link, the node on that link point to up.
This new node, right? So basically I just say current node dot, and correct me if I'm wrong, I'm just trying to phrase what you're saying. Set the link to the new node. Is that the idea?
That's what I think, but
Yeah,
Or-
that's exactly that's the idea. You take that current node, you set its link to the new node, right? That's exactly what the program does. So you say current node dot set link, or I called it current, didn't I? So current dot set the link to the new node, right? Okay. Now you'll see they're actually in order, aren't they? Rom, Carol, Van, June, right? Because
Interesting.
I added Carol after Rom, then I added Van after Carol, and then I added June after Van. So I didn't mess up with the ordering. I every time I wanted to add a new thing, I walked off to the end, just added a piece, right? But that's not what a list is. So I'm just showing you that this is actually what we were supposed to do in the last test, is to do that. Okay, so that's the idea. What we're really doing is we're just saying what we're really doing is we're just saying the the new node, take the new node, set its link to the head of the list, and then just make that the head. Okay. All right. We're talking about remove now. It's supposed to return a Boolean, so Boolean, it's going to be like the verdict, right? Whether or not it was removed, or you can call it removed. Initially, common practice tells you to just say, at first begin as though something didn't happen. So at first assume it's false. And then what you're going to have to do is you're going to have to first figure out if the thing you want to remove even, well, I think, you know what, we can use this exception first. So what should I write here for the empty case? Does anyone know?
If it's null,
If what's null?
the head or the list.
The list is null. throw new, so throw a new list empty exception. You could have a message here, right? So you could say, cannot remove on empty list. Okay, so let's okay, and then we'll also return false. I'm just so I can test it out. So we'll test this out. We'll come to list demo. We have nothing, and yet, despite that, we do my list dot remove. Let's say John. Okay, are we gonna? Oh, right. So it has to be in a try catch, right?
Mhm.
Surround with try catch. Okay. And then print out.
How'd you get that try catch to pop up?
Yeah. So so the thing is that when you write code that has an exception related to it, like whenever I use that remove method, it knows that it actually has an exception attached to
Oh,
it.
because you had written throws exception.
Exactly, because yeah, exactly. Like it will throw an exception sometimes. So I have to add, like if I do my list dot remove John, it's gonna say, well, hey, got to surround this in a try catch because it's dangerous code. So if I do my list dot remove John, and then it's the error. So if you hover over, this is true for all errors. If you hover over it, it'll tell you what's wrong or the best course of action. So over here, it's actually telling me what the best course of action is. I can surround it with a try catch. So I
Yeah,
surround. You see what I'm saying?
yeah, cool.
Yeah, and then this exception E, so system.out.print line, you actually just print out this exception. So you say E dot get the message. This is going to get the message that you passed in. Just get the message. So if I try to remove and there's nothing there, then I get the message cannot remove on empty list, right? So that's sort of the idea there with that. So that's if the can't do it. And so you're gonna first have to verify that it even exists in the list, right? How do I do that? So that means I'm gonna actually have to end up coding something else up first. What would that be? Find, right?
Yeah.
So how do I do find? I really want you guys to tell me how I do find. First of all, do we know what find does?
It goes through the list and checks equals whatever you're looking for. So you have to tell it what you're looking for, and then it goes through each node in the list.
Mhm. Yeah, for sure. Absolutely. So I have to do the traversal.
Mhm.
Okay. Well, the thing is, again, we take care of the edge cases. And, at first you might think, oh my God, when I code this stuff will never occur to me to think of this, but it will the more you do it. So the thing is like, well, if the list is null, if it's empty, well, then return false. There's no way it's ever, you can't have an item in an empty list. So if the list is null, you return false. Do we have common ground on that?
So
Well,
that's lines or no?
I'm sorry, go on.
No, I was just asking if that needs to be 2 lines.
Yeah, you could say 2 lines, return false. But this is usually when people have like 1 line, they'll just write it here. But yeah, for sure.
Oh, by the way, but just a heads up for everyone, she does not want you to have multiple return statements because she docked points from
Oh,
you.
dude,
Yeah,
yes, absolutely. Good point. Yeah, that's why I would remember when I was doing remove, I
Yeah.
had a variable
Yeah.
called.
Just
Yeah,
just make like a to return variable
yeah,
inside and you'll be
exactly.
chilling.
Yeah,
But yeah, just don't make the same mistake I did, guys. It's not worth.
yeah, she did that for me as well. So we'll call it found, right? We'll assume it's false to begin with. But the thing is that if off the bat your list is null, well, then it makes sense to just return false, right? There is no or not return false. Jesus Christ, found is false, right? Otherwise, right? So otherwise, well, we have to do the traversal, right? We have to look through each of the nodes, and then so does anyone know the basic template for the traversal of a list? How do I do that? The traversal?
No,
No?
I
Okay.
don't.
Okay. Yeah, remember what we said. Remember, we create if we want to traverse it, right? We create that traverse means to just walk down through, right? Or look through. So we create that current, we point it at the list, right? And then while that current is not null, we move it along, right? Oh, geez. Binary. Remember this one here?
Oh, yeah.
So maybe I must have been more clear. It's called traversal. This one, it's called traversal.
Yeah, no, you said it.
Yeah. So and we can sort of see this as well in like if you ever chose to venture out and like if you do linked list traversal, like linked list traversal, and let's say, you know, how to do this. How do you do this, right? So how to do linked list traversal, traversing a linked list, Java. See, so while the pointer isn't null, pointer equals pointer dot next, right? So first you take the pointer, you point it to the head, right? And while the pointer isn't null, pointer is pointer dot next. But for us, we just have different, we're calling it different things, right? We're saying while the the pointer for us is current, right? We point it at the head, which is list. While that current isn't null, move it, current equals current dot next. You see what I'm saying?
Can you repeat what you just said, just a little bit slower?
Yeah, absolutely. So what I was saying was like, you know, universally, this is how you traverse a linked list.
Mhm.
Is you take a pointer, right? And you could call this anything. You could call it a reference, you could call it current, you could call it whatever you want. And you point it at the head of the list, at the
Yep.
very end, right? Like we did. We said current equals list, which is, we said list was just the head. So and while that pointer isn't null, you set it equal to the next one in line.
Okay.
Right. So the pointer is at the head first, and then and again, I mean, this is just going back to kind of what we had here. You know, we set it at, oh, do you guys see the Figma, by the way?
The
No?
what?
The
No.
Figma. Okay, yeah, you take the current node, it's at the head of the list, and then while it's not null, move it down, right? And that's kind of what was being done over here. You take the pointer, point it at the head, and while the pointer isn't null, move it down.
Got it.
We're just calling it different things, right? Like pointer, we're calling current, head, we're calling list, and current equals current dot get link. You see how that's happening?
Yes.
Okay, so that was kind of the idea there. So we're just following. So that, you know, they'll have that up there sometimes. Like they're gonna condense it down. They're not gonna have specific things. They're just gonna tell you what to do. Have a pointer, point it to the head. While the pointer isn't null, pointer equals pointer dot next. This is the algorithm. Take the current, point it to the head. While the current isn't null, current equals current dot next, or dot get link in our case. But if at any given point the current dot, you have to get the data. If that data equals the item dot toString, then found is true, and you break out of it. And then ultimately you'll just return what found is. Was that too much?
For me, but don't use me as the highest
No,
common.
it's fine. It's fine. I'm gonna break this down. So first we have to get the data
Mhm.
within the node, right?
Mhm.
How do we get that? We let's store it. So we'll say, you know, data. Okay, it's gonna be current dot. How do you get the current data? Current dot get data, right?
Yes.
Right, because I'm just moving through the I'm moving through each of these, right? So, and each of them are segmented. They have data, right? So I need to check each of these pieces. I have to say, you know, what is the data equal to the data I want,
Hmm.
right? So I come here, I'm like, hey, current node, get your data, right?
Mhm.
So that's kind of what I was doing there. I was saying, okay, look, the data of the current node I'm storing in this variable called data. So I do that by current dot get data. Now, if that data, like the two string, because I'm comparing strings here, if that data dot, like if the, or I'll say current dot get data dot to string, right? Now, if that data equals the item, oh, what's going on? We cast it to T. Yeah, because I'm comparing strings, so you have to do dot equals. So if the data to string dot equals the item to string, then the found is true. So I store the data of the node that I'm currently on in data, right? So I say, well, data is going to hold current dot get data. And if that data, you can sort of filter out the two strings here if it helps to see what's going on. If the data equals the item, then found is true. Do you see what I'm saying? Like you're moving up regardless, like each time you're moving up. But before you move up, you check, is the data that I'm currently looking at, is that equal to the item that I'm trying to find? If it is, found is true. Does that make sense to everyone?
Yep.
Okay. But the thing was, instead of storing it into this data variable, I was just saying current dot get data instead. I was just doing that straight up, you know, out of the gate, right? I was like current dot get data, which is probably less readable. So I get the data first. I'm like, hey, does that data equal the item I want? If it is, found is true. But as soon as I find it, do I need to check anything else?
No.
I'll just break out. There's a bunch of ways to do this, like you know, there's another way, and I think this is the way she wants you to do it, the way she's taught in class, is like, okay, well, while the list is not null, and list dot, she'll get the data, and she'll say, okay, well, does it equal the item? Okay. She's going to move the list pointer up itself. So instead of creating like an external reference, she'll say list equals list dot get link. Okay. So does that kind of make sense? So eventually what's going to happen is either the list will be null and you won't find anything, or you'll find your item, right? And then you'll break out of this as well. But you know, I kind of prefer the latter method, which is like, you know, I have a current, it's, while it's not null, I'll just move through current equals current dot, you know, get link. And if I find it, I'll just say found is true and I'll break out of it. I'll return found, whatever that might be. If I never found it, if the data was never equal to the item, then found was never set to true, right? If I didn't find it. Does this method kind of make sense here?
Yep.
Okay. To string.
I wish I knew this last programming test. It would have helped so much.
Yeah. Yeah, unfortunately, yeah.
Now it all makes sense. So I mean that's an improvement for sure.
Yeah,
But I was lost for a while.
I would be surprised if she, I mean, when she said that she would make us do like create a linear data structure and we're not going to traverse it. I don't see that because she said it'd be hard. So I was like, well, traversing is hard. It's probably the hardest thing. Like you create you know, take a new node, tack it onto the list. While that new node isn't null, current equals current dot get link. Your logic goes in here. This is all just logic.
Yeah, last programming test, I spent a good hour on one line just trying to conceptualize all this, and I just couldn't. I just couldn't do it.
I don't blame you. I mean, I wouldn't be able to either if I didn't know it beforehand. This is one of those things that you just know beforehand. Honestly. So let's see if it works. Again, every method you make, you don't want to start making another method if you don't know if something works or not, right? So I'm going to do my list dot add, Carol, and let's see if I can get it, right? So I'm going to print out the value of the Boolean. So I'll say my list dot find. I'm going to ask them to find Carol. Let's see what happens. I don't know if they'll do it. I don't know. They're like, yes, Carol exists. If I change it to a lowercase c, it won't happen. They'll say false. Okay. That's the idea. So before you actually remove something, you have to determine whether you can find it. Can you even find the item? If you can find the item, if you pass the item to the find method and that is true, then you can just return true. Or don't do that, right? You'd be like, Boolean, or oh no, we're doing remove here, aren't we? We're not. We're doing remove. Oh, this is going to be a tough one.
I thought we already did remove, didn't we?
No, we just did find.
We did find. Yeah, this is a tough method over here. Like find is simple. Like it's like, okay, hey, if the list is null, well, guess what? Not finding Jack, right? Otherwise, just do this basic traversal thing. Like everything in between, again, that's just the logic. That will differ. When I was trying to print my stuff, like when I was initially when I was trying to print stuff out, I had the same current, I had while current not null, I had current.get link. I had all these things. The exception was in the middle in the logic. I just had system.out.println, current.get data. Or, when I was trying to add an item to the end, I had same current, same while current not null, current equal current.get link. I had all these things. The logic was different. I just took the last node, I attached it or whatever I did. So the logic is what is different. Jesus. So the logic is what is different over here. So what I do is I like, well, if I can pass item to find and it's true, then I know that it exists. Right. So I'll say Boolean remove Boolean removed. So if I can find it, then I should be able to remove it, right? And so the idea here is, let's see. I know how I would do it, but like I fear that everyone does it like that because it's so unique. It would help to maybe look at how she did it, but usually what I do is like, well, if I can find it, then I'll create that thing. I'll have to traverse again. Right, while current is not null. Maybe I'll have a node T. Well, okay, current does that for me. So really the whole removal process, it basically is established on if you have nodes, like this, the removal process is basically you just take, like, let's say this is the value that you want to remove, or let's say this is the value. The idea is that you have your current node. You check whether this is the item. If it's not, is this the item? And then you actually stop one before the item, right? So you're always asking yourself, or you're here, right? So you're moving through and you're like, oh, I found the item. So the idea is you actually have a previous pointer, and the previous pointer, what it does is it basically sets this link to this guy. It breaks it from here. Okay, that way, your linked list actually doesn't have this middle guy anymore. Okay, does that make sense?
If you were to say like you can't add any instance variables like last time, um like instead of like already having like a previous like instance variable like inside the remove, would you just have like would you make like two nodes and then the
Yeah,
previous would be like if that node dot like while that doesn't equal um like current node, that then like you just like and then you like join the it's I don't know how to explain it, but like
yeah,
like you just like you basically just detach it and like whatever.
yeah,
Is
yeah,
that
yeah.
okay?
No, for sure. Like, I mean, we didn't have any external variables in here. Like, the only thing we had was what we had on that exam, which was
Yeah.
like reference to the beginning. Um, and so over here in remove, like she says in the beginning, I believe, like you can have variables inside the methods to assist you, but you can't have global ones. You can have local ones. Local ones are ones that are inside the method. Global ones are ones that are on the class level here. So why she said you can't do the global one was because it could be easy just to make a tail pointer or a tail reference
Yeah.
over here, up here. And then whenever you wanted to add an item to the end, you just say tail.next is the new item,
Yeah.
right? But so she wanted to force you to traverse the list. And she wanted to like force your hand into saying, can't have a tail, traverse down this thing if you know how, if not drown.
Yeah, basically. Yeah, I drowned that day.
Yeah. So that was the idea there. And so we're doing the same thing here. Like we're gonna have a current node. The current node's gonna move through. It's gonna check each box, and as soon as it finds the box where the value is present, previous is gonna essentially, so it's gonna take its pointer, it's gonna point it to the next guy, like that. It's gonna cut link with this. Okay. So just to reiterate, like if current is here, prev will be here. That's kind of how we're gonna set it up, previous and current. If that sort of makes sense. Okay, does that make sense, the drawing?
Mhm.
Okay, let me see if I could do this. So you'll have a node current, or yeah, current. And then we also said we would have prev, right?
Yeah.
Equals. So it'll be null to begin with, because like why I say this is because initially when current is at the head, well, what's the previous? It's really nothing, right?
You're not on paint.
Oh, okay. Okay. Yeah. So I say this because like initially, when current is on the head, prev is actually pointing to nothing, right? There is no previous. This is kind of why I say this in the beginning. But this basically creates a big issue, in my opinion, which is if the head, like if what if I want to remove the head? How do I do that? See what I'm saying? Like if how do I remove the head? I can't say prev dot next is this guy because prev does not exist. So what I'm gonna do to take care of that is I am going to basically just say that if the list dot get data is the item that equals the item you want to remove, then I'm just gonna say list equals list dot get link. Does everyone know why I did this?
Um
Think about it. So I said, this is your list here, right? If this is the data you want to remove, well, I'll just take the list and I'll just move it one down. You see what I'm saying? The list pointer, I'll just move it one down so that this is not even a part of the list anymore.
Oh, okay.
Okay, so I had nodes like this, and then this was the list, and then this was the item I wanted to remove from here, right? And I was like, well, if the list item is the item I want to remove, well, then I'll just move this guy down here. And then when I start printing stuff out, or I start, working with the list, this is not going to even come in scope. Like it is not going to be a part of the.
Is it just an extra condition to make your life easier? Is that
This is
something-
I mean, this is a condition that, yeah, I mean, you have to take care of the, because think about it, like I can't do this. I can't say prev.next is equal to this guy. If I'm at the beginning, if I'm at the very beginning
Oh, okay.
and prev is here and current is here,
Yeah.
right? I can't say, oh, if current is the value I want to delete, then prev.next is this. Well, prev.next doesn't exist yet. So that's kind of what I'm doing.
Okay. I see.
Yeah. Let's test it out. I mean, and then we'll just return true for now. We'll just test it out. Let's see if it removes the head. Although the problem is that I don't know, let's see, this demo. Yeah. Okay. So if I do my list dot toString right now, I should get Carol, right? I should get Carol if I do my list dot toString right now. Yeah.
Woo-hoo.
But if I do my list dot remove Carol though,
Never remove Carol.
yeah, maybe, and then so if I do this and then and I do the toString again, see what I
Change
get
an
though.
exception.
Why
I
do
think
I
you should print as well.
print the exception?
No, print minus dot remove Carol.
I'm sorry, say that again.
I think you should print the 15th line. I'm not sure though.
Okay. 15th line over here,
Mm-hmm.
because it returns a Boolean, doesn't it? Right.
Yeah.
But I set it to always, true. We did remove Carol.
Meaning you truly removed, right? That's what that means.
Yeah, like I did
And therefore it's true.
yeah, but it's still a part of the list though. Let's see. List equals list dot get link. And then when I come down here to do the toString, current is pointing to list should be null, and then I should get nothing, honestly. Let's see here. I do the remove thing. I do the remove. There isn't an exception, but after I do the remove, I still get this mylist.toString. That is unheard of. Hold up here. If finding the item is true, and the list.getData dot toString dot equals the item dot toString, then I say, well, list will be the next guy in line. Right. And then I'll say, wow, that is shocking. It's very shocking because I added Carol. I did my list.toString. Obviously, it prints Carol. Then when I did my list, list is now, wait, one second. List equals list dot get link.
Graham, I hate to do this to you, but I got a calculus test tomorrow morning, so.
Yeah, sorry about that. Yeah, my
No,
bad.
no,
Yeah, I'll
this has
figure this
been awesome. This has been awesome. I can't say that I understood everything, but I understood some things that I didn't
Oh,
understand
for
before.
sure, absolutely.
So
Yeah,
that's a help to me. You said you are gonna do one of these tomorrow?
yeah, I'll do one of these tomorrow. I think I may have digressed too much here, with some tangents today probably. So I'll try to narrow the scope of things down next time, and that'll probably help.
Well, I mean, I appreciate what you did today and I appreciate your time for sure.
Yeah.
What time are you looking at?
I was thinking maybe 8:30 again. I mean, what's good for you and you guys?
Later's better, but I will try to make myself available. And if I'm not there yet, I would say start without me and I will jump on as soon as I can.
Okay, sure. Yeah, I mean they're recorded regardless. So
Oh, even better.
yeah, absolutely. Yeah, I think we'll just cover the queue tomorrow and then we'll wrap up there.
All
That
right.
should do it.
You're
Uh,
awesome. Thank you so much. And thank you everyone else for indulging, my stupid questions.
Oh,
Have a good night.
I wouldn't say that. Have a good one though, Carol.
All right, you guys too.
All right. Yeah, so I'm gonna try to figure the remove thing out tomorrow, but hopefully you found some sense of
Oh, yeah, totally, man. Was
Yep.
very helpful.
Thank you.
yeah, for sure. Yeah, and if there are any questions, then I'm happy to take them.
All right, man. Thanks.
Yep.
Thank you so much, man. Thank you. Take care.
You too. Bye.
Would you know by any chance when would this thing be up? The recording be up or wherever would it be?
I think I'll post it on my YouTube and then I'll send it to
Okay.
you. Yeah,
Got
it
it,
should
thanks.
be later tonight because these premium versions they pitch out the recording comparatively
Mhm.
quicker.
Okay, got it.
Should be
Thanks.
within the hour. Yeah.
Good night.
All right. See ya.
Thanks, Ryan.
Yeah, sure.